So let me just start. My name is Cindy Meyerson. I'm currently the president of the Data Vault North America Users Group. We want to welcome everyone to our Q2 event. And we also want to thank our sponsors. You'll be hearing from them as we go forward. We have changed the format of this event. The last few years, we've been running it for about 2.5 hours. We have reduced it down to an hour and a half. We are focusing on one presenter, and that will be Bill Inmon, which you'll see in our agenda. Mary, can you move the slide forward, please? Thank you. Just build that out. So just as an overview, if you're new to Data Vault, you can build the whole slide out, Mary. That's fine. I'm just going to very quickly go over some of the primary aspects of Data Vault. It is a system of business intelligence. It is built on three core pillars: the methodology, the architecture, and the model. It crosses, all of these pillars cross people, process, and technology. So when we talk about architecture in Data Vault, we are not just talking about a systems architecture. We're talking about, a people architecture. We're talking about a process architecture. Pillars cross all three aspects of what a true system of analytics has to include. When we talk about the Data Vault model, typically people think about the physical data model, hubs, links, and satellites as being physically instantiated. That is not really the case. You want to think about Data Vault from a logical modeling perspective, where hubs represent your business keys or your business concepts. Links represent relationships, associations, or events among those business concepts. And your satellites hold all of your descriptive data, either around the focus of a hub, meaning the business concepts, or the focus of a link, meaning relationships. And it holds all history, right? So we want to stay true to Bill Inman's description of what a data warehouse is, because we do not believe data warehouse has anything to do with technology at all, right? It is not something that's dead. It's what you build, which is a collection of immutable data from which the business can make a firm decision. All right, and so immutability of the history, immutability of the data set, auditability of the data set, all of these things are critical, we believe, to build a true system of information management moving forward with defensible analytics, which is what you're going to hear us talk more about over the next few years coming out of Data Vault. So it is scalable, resilient, performant. When we talk about it being atomic and historical, we're loading all of the descriptive data at the proper grain. So you have, atomic grain with history. So that's all I really want to say about this. If you want to learn more, obviously you're here. This is great. You're going to hear some of the methodological aspects of Data Vault as Bill talks about taxonomies and ontologies today. So if you want more information, you can reach out to the Data Vault North America user group, and there are other resources we'll talk about as we go forward. Next slide, please. So again, I'm Cindy Meyerson. We are a volunteer board, which may explain a little bit of the chaos that came in when we first started this afternoon. So I apologize for the delay there. But we are fortunate to have Jim Mihalik as our treasurer, Mary Mink. Mary actually founded Data Vault North America Users Group. It was her mastermind idea, and Mary comes from Resultant. Sam Ben Dayan has been part of this. Jody Wooten and Ramon, I'll probably pronounce your last name horribly, but Paravella, and they are new to our board. We're fortunate to have them, as is Jim Mihalik. He just stepped up this year as treasurer. And so Io is with event planning. And then we have an open seat on the board, just to mention that. If anyone is interested in joining us, please let us know. We have this VP of Technology Services that is open right now. So we do have an open seat for the board. If someone's interested, let us know. Next slide, please. Okay. So on our agenda today, we introduced the board already. We're going to hear from our sponsors next, and then Bill's going to get into his presentation. I'll introduce Bill in a minute for those who actually need an introduction. to let you know who you're talking and listening from today. We will have a 5-minute Q&A. We'll get into Dan's words of wisdom, and then we do have prizes for those of you who gave us your email. Thank you very much. You opted in. Our sponsors do provide a $50 gift certificate on Amazon, which is really nice for you for that information. And then we'll perhaps take suggestions if we have time at the end for what you might like to hear in September when we have our Q3 event. All right, next slide, please. Okay, so let's hear from our sponsors. I think, Mary, are you introducing it? Perfect.
Absolutely. So I just want to thank you for our sponsors, and we couldn't do this without you. And we're going to hear from Wearscape first, and that would be Alex Perry.
Hey, I'm Alex Perry. I'm a solutions architect with Wearscape. If anyone's been to WWDVC in the last several years, you might have seen me running around. Wearscape as a company goes back 25 years of experience in building data warehouses, and it's been used to implement Data Vault for quite some time as well. Personally, I've been using Wearscape for the past 4 years, mostly building data vaults. Wearscape as a tool helps accelerate the process of building a data vault from the conceptual model all the way up to the data marts that feed your reporting layer. It allows easy construction of hubs, satellites, links, and the pipelines that support that flow of data. You can check out our website at wearscape.com, and we'd love to get requests for a free demo from anyone. More than happy to help support people in their journey to build a data vault.
Thanks, Alex. Okay, and next we'll hear from Resultant Chris Waugh.
Hey, everybody. My name is Chris Waugh. I'm a client partner here at Resultant. We are a 400-person consulting data services firm and proud members, obviously, of the Data Vault community. So for those of you who were at the Worldwide Data Vault Consortium in Vermont last week, hope you loved hearing Mary's talk about this data-centric or business-centric Data Vault. And Mary's one of our practitioners, and as you can see, she's kind of very passionate about this and building these stacks the right way. So not only do we help build at Resultant, but we also help to assess. As you can tell, sorry, Mary. Thanks, Mary. We're passionate about doing this the right way. We're passionate about the principle of how to build this, but also very familiar in the full tech stack to power a best practice data vault. So we have full modern data stack capabilities, work with pipeline, warehousing, transformations, visualizations, Snowflake, Azure Fabric, Databricks, all of the above is right in our wheelhouse, and feel passionate about building a business-centric data vault to help drive real solutions. So if you need any help digging deeper into what a business-centric data vault might do for you, or in the middle of any sort of modernization, or just need somebody to come in from a best practice standard and look at what a data vault we have today and where it could be better, please feel free to reach out, contact me. I'd be happy to have a conversation. So thank you very much.
Thanks, Chris. All right, next up is Paul Kenyer from VaultSpeed.
Hey, Mary, this is Jeff. We did a little switch, so Jeff Petrosiak is going to be speaking. Thank you. Yeah, so I'm Jeff Petrosiak. I'm based in the Boston area. New to the Data Vault community here, so nice to meet you all. Hopefully, get to see you at some of the events moving forward. A little bit about VaultSpeed. We're a Belgium-based company. We've been around for almost 7 years. Our co-founders were building data vaults for 15 plus years, and felt the need that they wanted to build something that was visual for our customers to build out their data vault. So the easiest way to look at VaultSpeed is we're really automating that silver and gold layers, right? In the silver layer, in a visual way, we start from the conceptual level to help you guys build out your data vault, and that physical model, that business model, but also we go beyond that into the gold layer, right? You can see at the bottom, we support any native code for any of the big, cloud providers out there, Snowflake, Databricks, Fabrics. And then in the goal layer, we can help you build out their normal forms, star schemas, data products for the business. So we're really trying to be an end-to-end data platform across the board, but do it in an individual way. So you don't need to have any coding background. It enables the teams that you work with to be able to understand what you're doing. And you can see at the bottom right, we're helping customers deliver faster. We're proven in the market. Reduce manual by 90% plus. We have the ability to do delta generation, automate code generation as data changes, schemas change, and so forth. So, yeah, looking forward to hopefully meeting some of you guys in the future. You can reach out to us. I put a QR code there. If you guys want to have a conversation, we're happy to give a demo or just have a conversation how we can help you out. So, thank you.
Okay, great. Thanks, Jeff. And next we have Karsten Schweiger from Data Vault Builder.
Thanks a lot. Hi all, I'm Carsten from Data Vault Builder team, and I'm happy to share a quick summary of what Data Vault Builder is. Data Vault Builder is a business-driven data warehouse automation solution. It helps you to get the data ready for AI, data analytics, business intelligence, and all other data use cases. We are very proud that 94% of our customers report project success in less than 6 months, and they generate business value 10 times faster than with manual approaches or classic ETL tools. So what are we actually doing? Data Vault Builder supports two main processes, which we can see on the slide. First, the data flow from the sources to the target here in the middle. You can collect data from different sources, integrate it, and historize it in your single point of facts, the Data Vault core layer. From there, you can deliver the data in any format that your users need. For example, star schema for data marts, flat tables for data analytics, or knowledge chunks for GenAI or RAG applications, data products, or other custom formats. Second, we support the complete data warehouse development lifecycle. It starts with data modeling based on your use cases. We have a data profiler included, and from the model, we generate the full data flow automatically. That means we generate data structures, table structures, views, ETL jobs, pipelines, and the whole orchestration. We also support automated testing, data quality checks, and the deployment to different environments like dev test prod through a direct Git integration. With our operations module, you can schedule and monitor all your pipelines. On top of that, we provide automatic data lineage and always up-to-date documentation, which makes data governance very easy. And you can use our comprehensive API to integrate Data Vault into your IT landscape, and you can automate further around your whole DevOps process. In short, one tool end-to-end from source to AI-ready data. If you need further information, please just contact us on the website, get a demo, or contact me. Thanks a lot, and have a wonderful evening or afternoon in the US.
Thanks, Karsten. Okay, and next we have Robert Scott from Eon Collective, I believe.
Yep, I'm here.
Oh, good. Glad to hear.
Hello, everyone. I'm Robert Scott from Eon Collective. Those of you that know me that are on here, you probably know me as the former CTO and co-founder of Eon Collective. And fortunately, as of the end of last year, we're still Eon Collective, but we are now been acquired as part of a company which is the Formative Group. For those of you that know Rocket Mortgage and Rockbridge and so forth, and the owner of the Cleveland Cavaliers, who's not too very happy at the moment. They were actually the ones that we are a part of now, and we are the data arm for them. We are a company. Eon Collective has been around since the early 2014, 2015, with offerings in Data Vault around assessments, strategy, automation, implementations, and training, with a combination of a couple different things. One is a team that is responsible for solutions in the Data Vault and so forth space. But more importantly, we built out a platform called Adept, stands for Agile Design Environment for Process Transformations, where we utilize that for assessing not only the complexities involved for transitioning over to a data vault, but also utilizing it as a metadata-driven platform that integrates with some of our other partners that are on the call today for building out data vault as well. Proud to be here and look forward to the follow-ons with Bill Inmon for today's session. Thank you so much.
Thanks, Robert. Okay, next up we have Seven Rivers, and I'm not sure if John Price is with us. Are you here, John?
Yes, I'm here. And good afternoon, everybody. My name is John Price. I'm the CIO of Seven Rivers, based here in Milwaukee, Wisconsin. Seven Rivers is an elite Snowflake partner. We specialize in a variety of services, including Data Vault. We have deep expertise in Data Vault with over 80,000 hours of Data Vault implementations. We help clients implement Data Vault on Snowflake. We are a true blue Snowflake partner, but really we provide end-to-end solutions on Snowflake, but it's always based on a sound and resilient data foundation. And we believe that Data Vault is really the key to providing that. And then we help clients build out broader data strategies for which they can then leverage all of their data using Snowflake as well as other third-party tools on the platform. So very excited to be here and really excited to hear Bill Inmon later on today as well. Thank you very much.
Okay, thank you. Thank you, John. And next up, we have our own Cindy Meyerson with Data Rebels.
So I also run a company called Data Rebels. I'm president of Data Rebels, in addition to being the chief operating officer for Data Vault Alliance Holdings. As Data Rebels, we are an authorized training organization. I am a certified Data Vault 2.1 instructor. We offer official training. We're actually going to be coming out with some new training classes, so stay tuned on that. I'll have more announcements on that as we move forward. We offer training, as I said. We also run something called a Kickstart program. If you're interested in really taking a story or a particular problem and running it end to end in the course of about 10 business days, we run something called a 2-week Kickstart program where we come in and we will train your class, your team. You will be able to have them certified. It's actually the true certification class offered by Data Vault First CDVP 2.1. At the end of that 3-day training course, we dive right into a 7-day build with your team with a defined scope. And so if you're interested in sort of doing a kickstart, get your team up and running with some coaching and guidance, please reach out to me. I'd be happy to talk to you about that. We do offer coaching and guidance consulting for teams. If you want us to come in and just help, get you going, make sure the team is aligned properly with your objectives, that your data vault is being built properly, your processes and all of the aspects of it. Happy to, talk to you about that as well. And also we offer 4-hour workshops. If you have a specific sticky widget that your team is challenged with, give me a call. Let's talk about what we can do in 4 hours with your team running a workshop. So lots of options that you have. We're very flexible and we are fully certified. So anyway, thank you for your time and hope to hear from some of you.
Thanks, Cindy. And next up, we have Tybo from De facto.
Okay, well, he's not on here. What I'll say about De facto is they are an automation vendor, like many of the other vendors on the call today that are sponsors. You'll notice one thing, their earlier version of their tool did go through DVA's vendor certification program, and they did get certified, which means that their tool is capable of producing a Data Vault 2 compliant solution. So I'm not sure. I know they're working in areas of AI. I can't really speak to everything they're doing. They're doing some advanced work in that area. So I would encourage you to also get in touch with them if you want to know more about their product. So that's what I'll say for them.
Okay, thanks. Okay, on to the good stuff.
All right. Well, thank you all for bearing with us. I'm going to introduce my friend Bill Inmon, and I say that close to my heart here. So Bill is a widely recognized throughout the globe data in our industry as the father of data warehousing. That's a designation that he's earned through decades of pioneering work that fundamentally shaped modern enterprise analytics and information architecture. So he is the author or co-author of more than 60 books on data warehousing, analytics, governance, architecture, and information systems. His influence extends across generations of data professionals, right? Executives, technology leaders. He's done foundational work which established many of the principles that continue to drive enterprise data strategy today. So in recent years, Bill's research and thought leadership have increasingly focused on taxonomies, ontologies, textual ETL, and textual disambiguation, areas that are rapidly becoming critical to the future of artificial intelligence, large language models, small language models, right? So long before AI became a mainstream enterprise discussion, Bill was exploring how organizations could structure, contextualize, and semantically interpret unstructured textual information in order to transform raw language into meaning, right? So anyway, with no further ado, I would like to present Bill to you and have him take it away.
Thank you, Cindy. I appreciate those wonderful thoughts. And indeed, Cindy and I and Dan have been friends forever. I want to begin by saying that the presentation I'm about to do for you is taken from a monograph that we have on my Substack. I want to say just a few words about Substack. If you're looking for information, Dan and Cindy are on the Substack. There are a whole series of monographs that are relevant to success in our industry. And the monograph called "The Anatomy of an Ontology" is on the Substack site today. By the way, everything on the Substack site is free. Okay, you should now be looking at my screen one way or the other, and if you're not, then we have a problem. But that's what you should be seeing right now. If we can go to the next slide. Okay, when you get into the world of text, you find out that the world of text is as different from the world of structured data as night is today. It's like we are land animals, and suddenly one day somebody said, you've got to go live and swim in the sea. And in terms of oxygen, in terms of food, in terms of surviving, it's a completely different world. And so the world of text is also a completely different world from the world of structured systems, which most of us have been brought up with. So when we get into the world of text, we run smack dab into something called an ontology. And the ontology is a structuring of data, but it comes from the world of text. Now, today I'm going to try to show you both some theoretical examples of an ontology, and then I hope I can get on my computer and share with you some real examples of what these ontologies really look like. So in the world of text, you need something called an ontology. when we go into the world of ontology, it's quite natural to ask the question, what in the world is an ontology? How would I know an ontology from a football team or from a steak dinner or from a tennis ball? And the answer is you need to see what we're talking about. So a simple explanation of what an ontology is it's simply a collection of something called taxonomies. And so you can think of an ontology as something, say, for an airline. And in that airline, we would have a taxonomy for reservations, another taxonomy for flights, another taxonomy for the flight crew, another taxonomy for the gate agent, and so forth and so on. So what we do is we go out and gather up some of these things called taxonomies, put them together in a meaningful fashion, and then call it an ontology. Now, before we go any further, what are we going to do with the ontology? What the ontology is going to do for us once we've built it is it's going to allow us to read text and have an understanding of text. And I want to briefly go into some of the problems of text. Text is ungodly complex. I know when I started in the year 2002 on the work that I've been doing, I had no idea. You see, you and I speak in words and in text every day. Our brains think text is simple, but when you try to explain text to a computer, you find out it's anything but simple. Let me take a very simple example. Let me take the word fire. What does the word fire mean? You think you know what the word fire means, but I'm telling you, you don't. Why? Because fire can mean a conflagration. It can mean your house is on fire. Fire can mean taking a gun out and pulling the trigger of the gun. You fire the gun. Fire can mean your boss gets mad at you and the boss comes in and says, you're fired. So until you know the context of fire, you don't know what the word fire means. And our language is filled with these ambiguities. And so what the ontology is going to allow us to do, it's going to allow us to make sense of all of these pieces of language that are scattered about. So that's why we have a taxonomy. And so, again, a simple definition, an ontology is simply nothing more than a collection of meaningful and related taxonomies. So you say, okay, Bill, thanks for telling me that. What the heck is a taxonomy? And a taxonomy, again, a simple definition, is nothing more than a classification. And a classification of what? A classification of words. So as some simple examples of classifications, a type of a car might be a Porsche, Ford, Honda, Toyota, Kia, or Ferrari. A sport might be golf, football, tennis, bowling, baseball. Food might be steak, potatoes, tomatoes, beets, onions. And so you find that these are all simple taxonomies. And this is what goes into our world of ontologies. Now, when you get into the taxonomies that are put together, you can have, you don't have to have, but you can have a relation between the elements in the taxonomies. For example, we have country, states, and cities. And in the country, we have England, France, USA, China, Brazil. States, we have Texas, New Mexico, Colorado, Utah. Cities, we have El Paso, Santa Fe, Denver, Atlanta, and Miami. And what we can have is, we can say that the United States has the states of Texas, New Mexico, Colorado, Utah, Nevada, and Rhode Island. So there can be a relationship between one taxonomy and another taxonomy. On the other hand, we may not have a relationship. We see that Russia, China, and Brazil don't have any states. And this is perfectly acceptable when we're working with taxonomies. Then we go from states to cities. We see that El Paso is in Texas, Santa Fe is in New Mexico, Denver's in Phoenix, Denver's in Colorado. Phoenix, it's not in one of the cities in our taxonomy. And so that's perfectly okay. So there may or may not be a relationship between the elements from one taxonomy to the next. Here we see what might appear to be a taxonomy, but it isn't, because the subject matter of the taxonomy is country, and indeed we have England, France, and Russia in here, but we also have soccer, Chablis, egg whites, Babe Ruth, and other things. So this is not a taxonomy just because it's just a simple list of words. I'm not really sure what these words are put together for, but I can tell you it's not a taxonomy, because all of the elements of the taxonomy need to have the same relationship to the subject matter that the other elements have. And so this is how you would tell a taxonomy from a non-taxonomy. Next slide. Okay, taxonomies can be anything, and this presents some challenges to us. Taxonomy can be words. Texas rope sailfish. These are all words. It can be acronyms, intensive care unit, ASAP, AWOL, PDF, MRI. It can be misspellings. It can be languages, English, Spanish, Mandarin. It can be word families. Now, why this is a problem is that there are, for all practical matters, an infinite number of taxonomies. And so when you go about creating taxonomies and choosing the taxonomies that you put into your ontology, you've got to make sure that you are careful about the relationship of those taxonomies to the ontologies. Because we could sit here and think up classifications until we were blue in the face. And you don't want to do that. If you're going to be using text analytically, you need to be judicious in how you choose your text. So one of the major challenges of taxonomies and classifications is there's so many ways to classify things. Next slide. Another thing that you can find out, you run into, that's quite frankly very useful, and I hope I have time to show some examples of them today to you, is you can have multiple levels of classification within a taxonomy. You don't have to have just a single level, you can have multiple levels. So, for example, a food can be a meat, a vegetable, or a dessert. And a meat can be veal, chicken, or pork. A vegetable can be a beet, potato, eggplant, or celery. A sport can have a team or individual sports. A team sport might be football, basketball, baseball. Individual sports might have golf, tennis, bowling. So when you have one of these taxonomies, it is entirely acceptable to have multiple levels of classification within the same taxonomy. Now, you've got to be careful doing this, because the deeper you go with levels of classification, the more complex your taxonomy becomes. And it's been our experience that you want to keep your taxonomies as simple as you can. So having been doing this since the year 2002, which was my first experience doing this, I've never seen a taxonomy greater than a level 4 level of classification that was useful. Quite frankly, 2-level and 3-level taxonomies are the most useful. I'm not saying that you can't have one, and I'm not saying that there aren't useful ones that are out there, but I'm just saying that experience has shown as a rule of thumb that you want your taxonomies to really be no more than 3 levels of classification. Because if you make them more than those levels of classification, you run into complexities that you would rather not encounter. Next slide. Okay, so when we take a look at ontologies, we see that they have taxonomies within them. All of the taxonomies have a focus. You can have medical taxonomy, a legal taxonomy, business taxonomies. And in business, you would have such things as airlines, banking, insurance, railways, cruise lines, and so forth. So you don't want your ontology to start to encompass more than a limited range of information. Because if you try to make your taxonomies an omnibus taxonomy, you quickly run into complexities and trying to make the taxonomy work. So just a hint on your taxonomies from the very beginning, define what it is the taxonomy is going to encompass and then stick to that scope. If you need to make more than one taxonomy, hey, that's no problem. As you're going to see, hopefully in a few minutes, there's all kinds of ontologies that you can make. But for any given ontology, you want to make sure it has a very clean and clear focus. Next slide. Okay, let's take a look at what we mean by focus. Let's suppose that we have a North American landscape. So this is going to be the focus of our ontology, things that are in the North American landscape. Part of what's in the North American landscape are rivers. For example, the U.S. has the word Ohio, Mississippi, Missouri, Colorado, Rio Grande. These are all rivers associated with rivers found in the United States. What we wouldn't have would be the Nile River, the Amazon River, the Mekong Delta, the Ganges River. Those are part of a taxonomy for rivers, but not rivers for North America. So our taxonomies have got to be tailored to the intent of the ontology as well. And again, if not, why? Why do you have to have this discipline in the creation of your taxonomies? And the answer is really simple. The answer is complexity, because the minute you start to not have these suggestions for discipline that I'm telling you, you start to run into ungodly complexity. And so, there's a reason why I'm giving you these rules of thumb to try to make you as successful as quickly as you can. Next slide. Okay. As we've seen, some taxonomies can have a relationship to other taxonomies. However, some taxonomies have no relationship to other taxonomies. And again, that's perfectly acceptable. There's no law or rule that says a taxonomy has got to have a direct relationship, or the elements of the taxonomy have a relationship to any other taxonomy. So unlike some of the rules that we find in hierarchical relationships in databases, the rules of relationships in the world of ontologies are very loose. Next slide. Okay, some taxonomies relate to each other and some don't. So as an example, here we see an ontology for banking. Here we see the bank has credit cards, savings, and loans. And one way or the other, credit card, savings, and loans can be related to each other. But the bank also has a need for security and accounting. And so there's no direct relationship between security and, say, credit card and savings. No necessary relationship. In terms of accounting, accounting has, well, this is no, they have an indirect relationship, but not necessarily a direct relationship to the other taxonomies that are in the ontology. So again, the rules for building, managing, and using a taxonomy are very loose and non-restrictive as opposed to other rules we've had to live with and work with throughout our career. Next slide. Some taxonomies are generic across multiple taxonomies. Now, I hope we have time for me to show you some good examples of this, but what you're going to see is, for example, when you're building a banking ontology, you're going to need security, accounting, legal, and finance. And what you're going to find is that accounting, for example, is generic across multiple businesses. That GAAP, the general accounting principles, is created by a government organization, and it's true for every publicly traded organization, whether it be banking, airline, railroad, a restaurant, oil and gas, or anything else. So one of the things we're going to find is that there are such things as generic ontologies. Now, these generic taxonomies, these generic taxonomies can save your life. Why? Because if you're getting ready to build a taxonomy, let's take railways. Suppose you want to build an ontology for railways. You're going to build your ontology for railways with things like the freight train, freight, the cars, the railroad track, and things like that. But when it comes to the other aspects of the business, accounting, security, legal, you can simply go take the taxonomy that somebody else has done and plug it into your business-related taxonomy. I liken and again, I hope to show you some examples. The taxonomies are a giant Legos set that once you have them started and built, building an ontology is nothing more than taking pieces of a Lego and gluing them together as Legos are glued together. Next slide. Now, one of the things that people usually forget is that ongoing maintenance of an ontology and taxonomy is always a consideration. People think that you build these things and then somehow you're done building them. And I have news for you, that's anything but the truth. Now, the good news is that the first pass of building your ontology and taxonomy is easily the most arduous task. But as your business changes, you're going to be making changes to your taxonomy. The good news is that as your business changes, it normally changes incrementally. And so making an incremental change over time is not nearly as bad as creating it in the first place. We don't see General Motors going into competition with McDonald's. But if somehow General Motors woke up one day and wanted to go into competition with McDonald's, then all of a sudden General Motors would have, a whole new world to conquer when it comes to building their ontology. But I somehow doubt that General Motors is a candidate for doing that kind of thing. Next slide. So you're going to go down into Bill Inmon's personal collection of taxonomies. Now, I want to tell you, it's taken us let me go into taxonomies here. It's taken us about 6 years to build taxonomies. And far and away, the most difficult and challenging taxonomy is the taxonomy of medicine. I don't know if you know this or not. Let me tell you a little thing about the English language. The English language is purported to have around 660,000 unique words in the English language. Of those 660,000 words in the English language, 600,000 of those words are dedicated to medicine. And my wife happens to be a doctor, and occasionally I peek into her doctor's catalog or dictionary, and you've never seen such words. I promise, even doctors don't know all the words. And so trying to build the taxonomy for medicine took about 2.5 years. Let me very quickly show you what the medical taxonomy look like. This is the consolidated medical taxonomy. I hope to bring up for you here. Let's take a look at this particular taxonomy. It is a 3-level taxonomy. Column C is the actual word itself. Column B is the classification of the word, and column A is the classification of the classification. So that's what you're looking at here. Item number 1. Item number 2. You notice these things in brackets here. What these are acronyms. When you're dealing with taxonomies and ontologies, you've got to deal with acronyms. And in the world of medicine, acronyms are especially important because of the fact that doctors, airline pilots are probably the biggest, and military people are probably the biggest users of acronyms in the world. So your acronyms are part of communication, and they've got to be in your taxonomy as well. Then we get into the words themselves. And so here we see Acadia. Acadia is a pharmaceutical and is in pharma. Acanothia is from dermatology and is from the field of dermatology. Acarbose is something to do with diabetes and is a medication from diabetes. And so here we have every word that you would, let's find some more interesting words. Cribriform comes to us from dermatology. Crepitus comes to us from dermatology. Christi comes to us from research. Crohn's disease is a disease and is from the gastrointestinal community. So here we have every word, every medication, every diagnosis, every symptom, and every word that would commonly be found in the world of finding medicine. And it took us 2.5 years to build this taxonomy. There are about 13,000 words in this list. Yeast can be found in dentistry. X-ray is to examine somebody in pediatrics. Zoothromax, whatever that is a sexually transmitted disease, and this is a medication for it. So this is what a taxonomy in the world of medicine look like. Where did it come from? Okay, where did all of this come from? In the world of medicine, in order to do medicine, you had to break medicine down into their own individual taxonomies. For example, you had to do separate taxonomies for anesthesiology, cardiovascular, dermatology, diseases, emergency room processing, geriatrics, ear, nose, and throat, gynecology, hematology, etc., and so forth. And so let's just take one of these. Let's take dermatology, take a look at what's inside dermatology. And so when we take a look at inside dermatology, is we find the terms specifically related just to dermatology, which, by the way, happens to be one of the larger classifications. So we see that gathering all of this data and putting it into this form is a real challenge. Now let's go to the world of industry. And here we have some ontologies. Let me first just outline the ontologies. We have airline, banking, construction, cruise ships, hotel, insurance, manufacturing, oil and gas, pharmaceutical, public utility, railway, real estate, restaurant, retail, and communication. These ontologies are much simpler than the medical one. Once we got used to building them, we can build one of these ontologies in a matter of a week, no more than a week. So let's take a look at, let's just take a look at banking. We could look at any of them that you wanted to, but let's take a look at banking. So here we have the terms of banking. And so what do we have here? Again, a three-level ontological or taxonomical structure. Here again, we have a three-level taxonomical structure. And here is every word that you would find in banking. Now we start off with something kind of almost stupid, but here is .edu. And that's nothing more than a file extension that you would find in information technology. But when you're dealing with banking data, you need to know where something comes from. Then we get into such things as XML. What is that? That's extensible markup language. We get into XOF, which is a banking term for currency. XPF would also be a currency because you need the acronyms for the different currencies of the world. Then moving on down in the banking ontology or taxonomy, you have asymmetric behavior, which is unbalanced behavior, which is found in cities. You have the cities, in this case, of the United States. Astoria is Oregon in the United States. Assuming entity, that's an assumption of a loan, and that's a definition from GAAP. And so what we find here is the banking terms mixed with the accounting terms, finance terms, security terms, and so forth. So you see GAAP snuck in here, and here's another GAAP term, asymmetrical default. That's something that means somebody from GAAP. So what this means is we can take our list of raw words that we have here. We can read a document, recognize that this is a piece of information that's needed, and then go find the context. Your second level classification becomes the context of what you're looking at. Your third level of classification becomes the third level of classification of what a taxonomy looks like. So when you're thinking about taxonomies and ontologies, you often think in very loose, abstract terms. Believe me, the information you find here is not loose and is not abstract.
Like on the
I want to show you one more thing, and I'm sure my let me first let me find it, and I hope I can find it while you're still on board. I want to show you the miscellaneous arena. This is Bill Inmon's Lego collection, and here we have the darndest collection of pretty much everything you can think of. And this is where we go to find little bitty Legos and merge them together. So for example, animal food. We did a taxonomy for people in animal food. Now, in animal food, we have the very basics of animal food. We have the name of, for example, dog foods. So what we have here are every term that relates to animal to food. And we started with and have gone to dog food. So here we have the list of every dog food that's known to man. Should we want to extend this list, and this list is not extended. Oh, okay, we have cat food and other things. So this is a list of the different animal foods that exist in the world. We have all of these little Legos that you can use to quickly build your ontologies and larger taxonomies. And for example, billing, where is our gap one? Here's gap. So here is the every gap term that the accountant uses. We have the same thing for finance. We have the same thing for security. But this is Bill Inmon's collection of Legos. What this allows us to do, when somebody comes and says, I want you to produce a custom taxonomy for me, we only have to produce the very customized part of the taxonomy. We can go to our library of Legos and just pluck them out. And I want to show one more thing that I noticed while I'm going through here, is here we see, find up here, German. So how would you convert these things to a different language? It turns out it's actually quite easy to do that. You simply take your taxonomy, grab it in your copy area, send it over to the internet, and then do the conversion. And now, the conversion that you get when you go to the internet and do the conversion is about 90% accurate. It's almost never 100% accurate. So you still need to take the list of words that you have and have a native speaker go through the list and add things to the list. But starting off with a list that's already been vetted and doctored, and then doing the conversion from that saves you enormous amounts of time. So this is the Bill Inmon presentation on ontologies and taxonomies. What do you do with these? Well, you do a lot of things with these. The main thing we do with them right now is when people are building their LLMs, they do so from raw sources of text. And raw sources of text seldom have everything but business terms in them. When people write an article or a paper or something that has a raw amount of text in it, it typically includes a whole lot of things other than your business. So one of the things that you can do with the ontologies that we have for business, for example, airline, we can take any document and pluck out the airline business terms. And so that's what you end up sending to your LLM for processing. You don't want the million other terms that are in your document going into your LLM. Why? Because when you put non-business related terms in a document, it causes the processing of the document to go haywire when it comes to the cost. The number of tokens that you have in an LLM are exponentially counted in terms of the amount of processing that you do. So if you want to have your LLM behave as a proper LLM and not cost you an arm and a leg, you only want business terms in your LLM. So what you do is you use one of these ontologies, pass it through whatever document you're looking at, and it will pluck out only the business terms that you want in your LLM. There are a lot of other things to be done with the terms. You didn't ask me here to talk about the other things that can be done, but in terms of ontologies, this is an explanation of what an ontology is what a taxonomy is, how they relate together, what the rules of thumb are, practical rules of thumb for being successful with them, where they come from, how they're structured, and that was a lot to cover in the time that we have. So with that, I'm going to turn the program back over to Cindy.
Thank you, Bill, very much. We had a couple of questions that came in. Dan has been answering questions. Thank you, Dan, jumping in. We did have a question. I think Mary asked with regard to Inmon. She's saying in 2001, was Inmon your first project dealing with unstructured data? Can you talk a little about those efforts? We have a few minutes left before Dan comes on and then we finish up. Do you want to reserve this for another discussion with us and we have you come back and talk about a few other things in history, if you will?
I'll be happy to talk about that. And Enron is certainly an example of the way not to run a corporation. But I think Dan has got good things to tell us.
Okay. All right. So Bill, what I'd love to do is have you come back. I'm going to hold you on if I'm putting you on the spot, so I'm sorry. But I'd love to have you come back for another event with us and have a further discussion if that's good with you.
Love to do it.
Perfect. Thank you. Thank you very much for your presentation. I'm sorry about the technical glitches we ran into. I apologize to everyone for that. And thank you for bearing with us as we go through that. So, okay. Are you going to hang on with us, Bill, too? And just
for a little bit.
Okay, perfect. All right. I've got a lot of people jumping on the chat saying thank you, Bill. So much appreciated.
I'd like to introduce our next speaker, Dan Linstead. I'm sure everyone here knows Dan. Dan is is a renowned expert in data warehousing and is also the founder of Data Vault. So without further ado, Dan, giving the floor to you to share some words of wisdom for our team.
Awesome. Tonight, I'm going to keep it a little short. I'm suffering from a cold. And as far as wisdom, I get my wisdom from Bill. So, Bill, if I make a mistake, please correct me as you always do. All right. Here's the first thing. There's an elephant in the room. Everyone wants AI, but nobody wants to organize the closet. Large language models are incredibly eloquent, but they are statistically homeless. They have no inherent sense of truth or relationship. So if you feed an LLM raw data, as you heard from Bill, or a raw data vault without a taxonomy, you've given a genius a library where all the book covers have been ripped off and it has to guess what's inside, but it can't possibly know. Now, I would argue with the word genius there. I'm not so sure that LLMs are actually genius, but as Scott Ambler said at our conference, if you put a pile of garbage in to AI or LLMs, you get a landfill out. And I think those words are eloquent and definitely part of it. But in terms of taxonomies and ontologies, don't get bogged down in academic definitions. The links I sent are great references, but keep it functional for Data Vault, right? So taxonomy is the filing cabinet. It's like Bill showed. It's your hierarchy, your basic hierarchy. And I agree with Bill, no more than 3 levels deep. And as with anything, you can always categorize things 15, 20, 100 levels. But then you can't find anything because you don't know where you put it, right? So 3 levels deep is manageable by the human brain. That's usually what it turns out to be. It's knowing that a customer is a type of legal entity, as Bill indicated. Ontology you could think of as the social network. It's the logic. It's knowing that customer purchases a product via a contract. So describing the relationships between the nouns. Sound familiar? That's because in Data Vault landscape, it is. We use nouns for hubs and we use relationships for links. Just bare bones definitions there. So we're building a sort of a graph network, and Doug can talk all about that. We're building a graph network with our elements. The relevance in Data Vault, like I just said, hubs are your entities, and ontology is the soul of your links. But it's not just the link alone. Surrounding the links are the satellites that hang on the links, and those are the data warehousing aspect of data over time. Those are your context, your descriptors. So it defines why and when these two keys are associated or these multiple keys are associated, and it describes some other attributes, if you have them, about what that association might mean to the business at that time. So those are the ways to think about taxonomy ontology at a basic level. So Data Vault was built for change, right? Everybody knows this. Data Vault handles the physical reality of disparate sources. Ontologies handle the semantic reality of the business. And that's important. But don't think for a minute that having both answers all the questions you need. It doesn't. You have to cross the semantic gap into the physical and technical world. And that's where we talk about extended taxonomies and extended ontologies. Being able to identify, this business key ties to these 15 source systems, and this same business key ties to this concept or this logical component or this area in the taxonomy and in the ontology. Pulling that together or stitching that together, that's where the magic happens, right? So you aren't just building tables, you're actually building a knowledge graph when you build data vault structures. And it's been this way since the beginning. This is by design. This is why we jump up and down and say, never ever build a source system data vault. There's no business value there. You have to do the integration on the business keys, the business concepts, and the taxonomy. You got to tie it all together. So it matters because it takes your vault from into a future-proof state. And when the next AI model or thing comes along, you don't re-engineer the data, you just update the semantic gap. And I think that's the most important lesson. How does Data Vault fit with taxonomies, ontologies? As far as the model and the storage of the data in a warehouse is concerned, it becomes your system of record to feed your AI engines. So instead of feeding your AI engines a ball or a boatload worth of garbage, you feed it at least some semblance. And yes, you've got the good, the bad, the ugly data in there, but you've done some semblance to connect things by business key as well as relationships. So you've brought some form of a knowledge graph into the data set that you can then leverage inside your AI. So it reduces your landfill and hopefully gives you some semblance of organized output, right? I've even heard some of the AI experts out there who know Data Vault say they won't source anything else because they simply don't trust it. So this is part of the defensible analytics that you're starting to hear us talk about and write about. So, the three pillars here: don't boil the ocean, start with a micro ontology, or better yet, a micro taxonomy. Start with 10 or 5 or 10 terms, maybe 15. As far as scope is concerned, get used to it, get familiar with it, and then build in your relationships, which gets you the micro ontology. Scope, scope, scope. Scope your way to success. So keep your scope small, build it, use it, learn it, and iterate, iterate, iterate. Now, you can also use a tool called Protege, which is free, available from Stanford University, I believe. Someone could put the link in the chat for that. You can use a tool called Gephi, and Doug can share some of his research around knowledge graphs and Gephi, and what he's been doing with taxonomies, ontologies, and as far as data vault modeling is concerned. Some very powerful stuff. The second lesson here is logic over labels. Focus on the relationships, i.e. the links. Why do you think they're there? Don't get away by saying, I don't need links. That's a load of hogwash. That's like saying an ontology doesn't need relationships. That is complete and utter, hogwash. So in the AI context, the link is often more valuable than the context itself. The fact that you know that there was a relationship there between two or more keys or two or more business constructs at some point in time, it's very, very telling. Even if the business says that relationship should not exist, you now have data to say, How much of the relationship, how much of the data, or how much of the business has that relationship? When was it effective? And then you can counterbalance that against the perception of reality in the business. Is this relationship valid? No, it's not valid today, but it was valid between this point in time and that point in time. And that's what the Data Vault can help your AI engine determine, is the validity and the scope. Once you can see the gap between the two, AI is very, very good at helping you close that gap, or using gap analysis protocols. That's what it's best at, to figure out how wide the gap is and whether or not that gap can be closed or should be closed, and how to do it. So the third item here, or the third pillar, be the bridge. Tell the group that the Data Vault professionals are the natural semantic architects. You really are the natural semantic architects of the AI era. So yes, I was reading that point. I didn't want to get it wrong. This is important. It's supposed to be words of wisdom. These are just my speaking notes, so I apologize. But this is our future job. If you don't understand taxonomies and ontologies here, and you don't understand, how they relate to the data sets you're building in Data Vault, then you probably won't have a job in the future, and you certainly won't be able to leverage AI the way it needs to be leveraged and governed. So in the age of AI, data without a taxonomy is just noise. Absolutely. If you can't categorize it, you can't define it. If you can't define it, you can't understand it. That's, pivotal or paramount to something that Bill just covered. You can't understand what you're looking at until you organize it. So you've got to define it and then organize it and keep track of it. Otherwise, it's just noise, and its logic without an ontology is just a guess, right? So without relationships, you're just guessing. You're using fuzzy logic to say, well, I think these two things are correlated, but I can't be sure. You have a very low confidence, or the AI engine has a very, very low confidence, unless there is data driving that confidence and that strength. So very important. So your Data Vault is the foundation of truth. Give it the vocabulary so the rest of your business can finally understand it. That's it for words of wisdom. Questions, thoughts, comments?
Thank you, Dan.
You're welcome.
I believe we're coming up on the agenda for the prizes, Mary. Is that right?
Right. And I just want to again thank all the sponsors, and we've got, their emails if you'd like to get in touch with any of the sponsors to help you out with your projects. And next, Jody is going to talk about the prizes.
Thanks, Mary. So we have 8 prizes today. Each of our sponsors has donated a $50, 7 of our sponsors have donated an Amazon gift card, and then we have an Audible gift card from Eon Collective. So if you go to the next slide, we'll see these were drawn right before this meeting, and our winners are, we have from Resultant is giving a $50 Amazon gift card to Kamar Vasan. And those with the double asterisk are new to the Data Vault or DVNAUG meetings. So welcome and thank you for coming. So first time winner and first time attendee. Our second, Data Rebels, is given a $50 Amazon gift card to Muhammad Shaban from Alexandria University. So if you are on this list, the winners are the sponsors will be reaching out and getting these prizes to you. The winner for Eon Collective is Raul Hubbleman, and the company is he is from Procaspert AS. And then Warescape, our winner is Mary Beth Dawes from Knights of Columbus. And from VaultSpeed, we have Aditi Potnuru from Fiserv. And then Seven Rivers is given a $50 Amazon gift card to Madhu Bahamridi from Data Echo 360. DataBot Builder is given an Amazon gift card to Chris Taylor from Excelsior University. And De facto is given an Amazon gift card to Mark Roden from Mosher. Again, thank you to all of our winners. You'll be in contact from our sponsors. And we had 4 first-time DVNAUG winners, or attenders, and then winners. So thank you all for coming. And we thank you to Bill and Dan for their great words of wisdom.
Thanks, Jody. Appreciate that. Our next DVNAUG event will be on September 9th. And we will be filling you in on the next speaker. We've had some interest from several folks, so we'll be selecting the next speaker. If you have other suggestions, if anyone is interested in hearing from a particular speaker, please let us know, because we're here for you. So we want to be able to deliver things of interest to you. So let us know. Okay. Well, we just want to thank everyone for being here. We hope to see you back on September 9th. Be looking for some announcements on our next event. Thank you to all our sponsors, as Mary said, and for all our board members and our wonderful announcer, Noelle. I'm sorry I kind of jumped in without the agenda, and I took that over, and we missed your wonderful broadcasting voice. So my apologies.
Maybe we can let him finalize the meeting.
Yeah,
Is he
you want
here?
to finish us up, Noelle?
Well,
Oh, here we go.
can you hear me?
Yes.
Yeah.
You can.
Do you have a
Okay. Well,
joke or
you know what?
something?
I have a pro tip. All right. If any of you go into the office, I want to let you know that what you need to do is hide. This is the best way to get in good with your boss. You know why? Because
Why?
good workers are hard to find.
Oh, that's great, Noelle. Thank you. That's good.
And with that, I hope that everyone can join us back again in September, and we'll take care of yourselves between now and then.
All
and
right.
work with data.
Thank you.
Thank you, Noelle.
My pleasure.
Thank you, everyone.
Till next time.
Thank you.
Bye.
Bye.